Alright, so what I am trying to do here is to try to do a unlimited thread build using make j and then nothing in front of that. So what the j flag does is whenever you build Aosp, it goes ahead and kind of paralyzes the build. Yeah, paralyzes the build in a way. So it can consume all 8 threads on the build system. Now I do have 8 threads, and my previous build with make J8 did it in 22 hours 41 minutes. And what I now want to do is go ahead and make J without anything. And what that does is generates or creates threads, unlimited threads, virtually unlimited threads, so not truly unlimited, until unless it hits a dependency. Further than that cannot continue. So this should give us a pretty good, pretty high load average. Now, right now the load average seems low at 1.3, 1.13. If the build is executing as it should, the load average goes up to 8. So that's one per core. So the load average should be one. And then anything, if it's a 8 core CPU, it goes up to 8. Again, 16 core CPU goes up to 16 and things like that. With make j, load average should, I'm expecting to go up to 32 or something, because that what happens with bitbake. The load average goes up to 32. That means with 8 cores there are 32 pending jobs, to put it very roughly. So let's go ahead and hit make j8. I have run make clean as well as ccache clean, and let's see what kind of time we get. Again, this is just part one, because I am not expecting the build to finish like while I'm recording. It takes about 2 hours. I'm not sure if it would have um, any performance improvement. So as you can see, just from the start, the load average has gone up to 14, which is insane. I mean, and it's not even started to compile. It's just getting things ready, so to speak. And if it would focus, so right now it's just scanning through all the .mk files it can find, and kind of making sure all the dependencies are in place. About 849 files to scan, not a big deal. So for those who are wondering what the hardware is, it's Intel Xeon laptop, about 3.10 gigahertz base and 4.2 boost, and you can see all the status there. 3.10 base, and it goes up to 4.2 on average. So now it has started to build, and I am not seeing an increase in load average as I should, which is surprising, because with bitbake I usually get 32 or something. So it has gone to 8, and this is what it should be. And down here we are hitting at 3.7 gigahertz across all cores. So it looks like what's happening is make, even though it's trying to get unlimited threads in there, it's just being limited, which is not what I did expect. But yeah, it's like load average went up to 9, which is kind of, now we are in the area where there are threads waiting to be processed and there's not enough cores. So load average is greater than nproc, or number of CPUs. Let's wait for a few more seconds and see how this goes. Load average is up to 9.72 and it seems to be slowly increasing. Cool. And on here, 3.6 or 3.7 gigahertz nearly at around 83 degrees Celsius, and all four fans are all time high, 3600 RPM. Maybe you can hear it. I don't know the phone's microphone. I don't know how well that does. And yes, the load average is up to 10. Yay! Let's see how high it can go within the next few minutes. And then I'll actually come back once the build is done and see how long it took. I mean, even with something like Bitbake, where the load average goes up to 32, and that's, I think, not purely related to compiling the OS itself, but also downloading the source code, because Bitbake doesn't have pre-downloaded source code downloads where while it makes them, and then there's the configure and step, and then a bunch of other things. Whereas AOSP, what it seems is potentially goes straight into building everything natively. So yeah, Bitbake has a lot more to do, a lot more on its plate, which is fine. We are up to 10.2 on the load average. 1 minute load average is 10.20. Now it has come down, and 8.26 on the 5 minutes and 5.30 on the 15-minute load average, which is pretty good actually from what I was expecting. Nothing's on fire yet. We are at 82 degrees Celsius, which is fine. Room temps at around 24. CPU clock is at, just dropped down. It's at about 3.7 or something. Good. Interestingly, yes, this by for someone who's wondering what the UI is, the thing here is the graph. It's a program called STUI. I don't know. I think it's based on Python, but I'm not sure about that. However, it's a really neat little graph system start application. Even gives you the CPU power, current CPU power consumption, and this 2.5 watts, and it can show watts at once. So that's what I noticed with this app. We are up to, I think we have stabilized at like around 10.41 load average. So we just have like two jobs more than the number of cores we have, and it seems all fine and dandy. All right, so I'll go ahead and stop the stream here, and what we'll do is come back later once the build is done. In the meantime, I'll record the next video that is to be uploaded today, hopefully in a few hours. We are at 7% of our build, and I'm not sure how long it has been. Yeah, around 9 minutes. I've started the video with the build, so yeah. Alright, cool. See you all later. Bye.